Hey guys, welcome to 75-day lead code coding challenge, and today we are going to solve our next problem statement, search in a binary search tree. So let's start. You are given the root of a binary search tree and an integer value. Find the node in a binary search tree that the node value equals value and return the subtree rooted with that node. If such a node does not exist, return null. So we have given a binary search tree and given a node value. We need to search the node with the given value. So for this the value given is 2 and this is the node that we need to return. Let's discuss what is binary search tree and how we can solve this problem statement. So in binary search tree, if there is a root, the left root is always less than our root value, and our right root and our right node have the value greater than our node. So if our root node have the value of 1, the left sub node have the value less than the value of the root, and the right have the value greater than our root. So let's say 8 0. Similarly, so this is the valid binary search tree. Let's create another one. Let's give some bigger value 5, and we can say 1 and 10. So here the uh, left node have the value less than our root node, and the right node have the value greater than our root node. Then again we have to do the same process. What is less than 1? Any value less than 1, let's say 0, and greater than 1 we can say 4. Then here also we need to have value less than 10, 7, and some value greater than 10, let's say 12. And for this 4 also we can do something less than 4, 3, and greater than 4. Uh, let's say make it 3 so that we can write 4 here. So I made it 3. So this right subtree node, the whole subtree subtree have the value greater than 5, 10, 7, and 12. All the value was greater than 5, our root node. And in the left subtree, all the values less than the 5, 1, 0, 3, 4, and we can write 2 here. Sorry, we can write 2 here. So it is 3, 2, and 4. So all the value less than 5. Similarly, for this node also, one left subtree of the value uh, less than the root node, and the right subtree have the value greater than the root node. And similarly, here is 3, here is 2. So left subtree have the value less than the root node, the right subtree have the value greater than the root node. Similarly, here also the 7 is less than 10 and 12 is greater than 10. So this is a valid binary search tree, right? And we need to find the given node in this binary search tree. So let's discuss how we can solve it. So suppose we have given the value of 7 that we need to find. So to travels across the tree, we can check from the root. If our given value 7 is greater than our root value, if our 7 is greater than our root value, then we know we need to move to the right subtree. So move right subtree, right? Because in the right subtree, the all the node have the value greater than our root node. And if our 7 is less than our root value, then we need to move to the left subtree, right? Because the left subtree, all the node have the value less than the root node. So we can keep on taking decision based on the condition satisfied. So for first we check if 7 is greater than root node or node. So 7 is greater than 5, so we move to the right side of the direction. And again we check from the root node, if 7 is greater than 10, it is not, but 7 is less than 10, so we move to the left side, and then we find our root node, right? And if by moving according to the condition, we do not find the node, then we can say there is no node exists with the value, right? So let's do this in the let do the coding part for this, and we can use recursion to do the traversal like this, correct? Well, let's start. So we are saying if our value given is greater than our root node value, right? So this is the first condition. If our value given is greater than our root value, we move to the right subtree side. So return, we know that our node exists in the right side. Yes, root dot right comma value. Similarly, if our value is if the given node is not exists in the right subtree side, we can assume it is exists in the left side of the binary tree. So if we are not moving to the right side, let's move to the right left side. If at any node, if any root node we find our value, if our if at any node we find our value, we return the we did return the root node. If at any node we find the value, we return the node. One more condition to check: if we do not find the node at last, we are moving left and right and left and right and so on, and we are not find our value in the given binary tree. So if our root goes null while traversal, we assume there is no value exists in the node, so we return the null value. So our so we are done with the coding. Now let's run the code and check if our test case is running. Search BST. Okay, so this is all capital BST and BST. Okay, so our test case is working. Now let's run the submit the solution. So our solution is also working. And thanks for joining the session. Let's meet tomorrow.